B. Intrinsic geometry, exterior algebra in three-dimensional. B. Part 1, manifold. B. Part 1, lecture 6. What is a chart? By the way, in the next video, I will develop a numerical example just to make this for more clarity. You see, this will be lecture 7. But now, a chart takes a point P on the manifold M3 and assigns it a set of 3 numbers describing its position in some coordinate system. If the map alpha minus 1 is used to construct the chart, then it serves as a way to retrieve local coordinates from an external reference space. In this case, it's called the fantasy. You can use any fantasy just to describe, to get the chart. Okay. In other words, a chart is a function that assigns coordinate to points on a manifold. Specifically, a chart phi is a smooth function. You see this smooth function. U is a chart, okay, contained on the manifold M. You see, and leads to, in this case, three coordinates, okay? Then U is an open set of M, and phi of P gives a set of 3 real numbers. It's a local coordinate for this case, for each point P that belongs to the chart. You see? Now, this is a recipe that we will use in the next numerical example. From the previous lecture 5, give the function gamma of lambda. You see, these are the 3 coordinates, you see, Euclidean coordinates, where epsilon, lambda is in this case, is an increment, okay? That lambda is a variable, okay, that stays in this interval here, okay? And gamma 0 is the point, this is a point P that belongs to both the manifold and the tangent space, okay, the tangent vector space, okay, as we pointed out in lecture 5. Now, given linear map alpha such that alpha acts on P, it leads to the point Q according to the figure here. You see, this is a point P belongs to the manifold. Alpha is a linear map, okay, that this case acts on P and result of point Q. This is a space fantasy. Attention, this is Euclidean space, okay? Now, this interval is not infinitesimal interval, okay? This is epsilon minus epsilon plus epsilon, as I pointed out, I described in lecture 5. That's a point, okay? Alpha will act at this point P over here. There's a point P, okay? Then results, maps on this point Q, x1, x2, and x3. Cartesian, okay? Cartesian points here. Now, attention now. This is the map. The map brings points from Q to the manifold. That's important. You see the point P over here, so it's there. Now, obtain the chart U. Okay. Now consider set of points close to Q. You see, after we obtained point Q, okay, using this map, then you move back, okay, from this the space, the fantasy space, to the manifold. Okay, just bring using the inverse of alpha. It's clear, okay? Now, you consider a set of points close to point Q. Okay? To create a chart U, just apply the inverse of alpha minus 1. You see? Then you bring, so this is the chart. Again, this function phi, you see, acts on points on U, okay, and leads to points in R3, where phi gives a set of 3 real numbers, local coordinates, for each point in the neighborhood of P. See, that's it. You will see this more clear in the next lecture. We apply this lecture 6. Okay? We apply to a numerical example.